Our lesson today deals in writing names and formulas for binary molecular compounds. Binary molecular compounds differ from the ionic compounds we have been naming. Ionic compounds were made of a cation and an anion. The binary molecular compounds, as the name implies, are made of two items, since it is binary, but they will be two nonmetals, unlike the cation-anion combination of the ionic compounds. Because they are made of two nonmetals, we're going to see that both elements in the formula will show up to the right of the staircase on the periodic table. We will still follow our rule for naming, where the more italic element must go first in the written formula. That, as a reminder, the more metallic element would be further left on the periodic table or further down if in the same group. For example, carbon monoxide, CNO both in the same period, carbon is further left, and that is why it appears first in the formula. If I have two elements such as sulfur and oxygen that are in the same group, we see sulfur is further down in the same group, therefore is more metallic and will go first, such as in the example of sulfur dioxide. What happens if we have two elements such as fluorine and xenon that are going to form a binary molecular compound? In this case, xenon would be considered more metallic because it is further down in terms of the period. That is a more significant factor than the fluorine being further left. So in the example of xenon and fluoride in the formula XeF6, xenon goes first for our compound of xenon hexafluoride. We will see that all the binary molecular compounds will still end in IDE because the second element in the formula is a nonmetal. So that is following the rules just as they did in ionic compounds. The nonmetal ending of IDE. The first element in the formula will be simply named, again, just as in the ionic compound. But we need some distinction so that we can immediately see from the name that it is binary molecular and not ionic. So what is done? We are not balancing oxidation number. We are going to use Greek prefixes to tell the number of atoms. So your subscript will equal the prefix, a very simple format. You're already familiar with most of these prefixes from your math class. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pay attention to hepta. For whatever reason, that is one students seem to forget more frequently than the others. So, if we have 3 sulfur atoms, we would say trisulfur, and we'll look at some examples to explain that. Carbon monoxide, CO. We see that both elements are to the right of the staircase, and so we know we need to use the Greek prefixes. The prefix will equal the suffix or the subscript. We have 1 carbon, 1 oxygen. We use this example to illustrate one special rule. If there is 1 for the first element in the formula, we do not use the prefix mono. However, mono must be used if the second element in the formula is only 1 for the subscript. So carbon monoxide, IDE ending with the second element in the formula only. so CO2. Again, C, my first element, is to the right of the staircase. I know I need Greek prefixes. 1 carbon, 2 oxygens, so carbon dioxide. Our next example, N2O4. Again, I find my first element, nitrogen, to the right of the staircase. 2 nonmetals. I know that I need to use the Greek prefixes 2 and 4, di and tetra. First element just gets named with a prefix, so dinitrogen. Second element, IDE ending, tetraoxide. How about looking at the difference between SO3 and SO3 2-? Notice SO3 is a compound, while SO3 2- is an ion. As I see, it has a charge. So they must have different names. SO3 is 2 nonmetals, both to the right of the staircase, so I use my Greek prefixes to be equal to the subscript. First one I have 1. I do not use the mono, so simply sulfur trioxide. SO3 2- is a polyatomic you needed to know in a previous lesson and would be the sulfite ion. Let's do a few more for some practice. First example, N2O5. Develop the habit of finding the first element on the periodic table. It is to the right of the staircase, so I know that I need to use prefixes to name it. I have 2 nitrogens, so the first part of the name would be dinitrogen. The oxygen, penta for 5, must end in IDE. Full name, dinitrogen pentoxide. Our next example is going to be giving a name, and you write the formula. Xenon hexafluoride. When going from the name to the formula, look for clues. I have a Greek prefix, so I know that I am going to use subscripts equal to the prefixes. Xenon, I have 1. Fluoride, I have 6. So XeF6. 2 nonmetals. That's why we are using the Greek prefixes. What about writing a formula for a molecule made of 4 hydrogens and 2 phosphorus? Reminder, using the term molecule, when used correctly, means they are compounds made of 2 nonmetals, or more in the case of organic compounds. So I find my hydrogen and phosphorus on the periodic table. They are not in the same group or period, so being further down in the periodic table in terms of period is more significant. The phosphorus is more metallic and will appear first in the formula. So my formula would be P2H4. When naming it, 2 nonmetals, use my Greek prefixes, diphosphorus, tetra, my prefix for 4. A reminder, here the hydrogen is in the second position, must end in IDE, tetrahydride, so the full name, diphosphorus tetrahydride. A reminder, we only use the Greek prefixes in naming when we have inorganic compounds that are made of 2 nonmetals.